Namaskar, I'm Harpreet Kaur and I welcome you all to our live and interactive session. You're watching us on PME Vidya channels 9, 10, 11 and 12 and also on our YouTube channel NCERT Official. Well, this is a special webinar series titled Listening to Learn. This series is presented by Department of Education in Science and Mathematics NCERT New Delhi, and today we are in the 93rd session or edition of the series. The topic that we have taken up today, I would say the topic of discussion, is Naval Architecture and Shipbuilding. We will learn a lot about it with an eminent personality that has been joined with us. But we will reveal the details in a while to you. Before that, let me tell you that this session is live and interactive, which means you can participate in the session as well. And you can also share your feedback with us. Please take down our phone number, which is 8800440559. In case you wish to send us your email, the email ID is dth.class12@ciet.nic.in. And since we are streaming live on our YouTube channel NCERT Official, you can always go to the comment section, put in your relevant questions there, any doubts, suggestions or your feedback and get in touch with us instantly. Well, we all are, quite, I would say, curious to know about the life in sea, and we have been conducting sessions of late that are more or less revolving around the life life at sea or in sea. Now, what today we are going to tell you is actually quite interesting. But for that, we are joined by two experts. So, of course, I will introduce him to you in a while, and let me tell you that we have been conducting so many sessions in this beautiful series of ours. If you wish to learn more what all sessions we have conducted, if you wish to watch them, then there is a special link. We request you to kindly log on to the same. It is ncert.nic.in/webinar_series.php. This is a treasure of wisdom that of course you can fetch from this link. And now let me introduce you all to the man behind this entire initiative, Dr. Gagan Gupta from DESM NCERT, who will take the conversation forward. Sir, namaskar and very warm welcome.
Thank you, Harpreet, and दोस्तों बहुत बहुत अच्छा नमस्कार आप लोगों को, बहुत बहुत शुभकामनाएं। नया साल आने वाला है थोड़े दिनों में और आज हम अपना 92वां सेशन कर रहे हैं, 92nd। और आज का सेशन हमारे लिए बहुत ख़ास है क्योंकि आज हमारे साथ जुड़ रहे हैं एक सेलिब्रिटी, कैप्टन NS मोहन राम, जिन्होंने कि इस देश में बहुत उत्तीर्ण काम किया है, बहुत उत्कृष्ट कार्य किया है। हम बहुत लकी हैं कि आज वो हमारे साथ हैं। दोस्तों, इस सीरीज़ में हमें आप लोगों का साथ लगातार मिलता रहा है और मुझे पूरी उम्मीद है कि आगे भी मिलता रहेगा। आप अपने सुझाव हमें लगातार भेजते रहें। जैसा कि मेरे साथी हरप्रीत ने बताया कि आपको पुराने सारे सेशंस हमारे ncert.nic.in, जो कि हमारी ऑफिशियल वेबसाइट है, इसके इवेंट सेक्शन में आपको सारे सेशंस मिल जाएंगे। आप ज़रूर देखिए। हम कुछ दिनों से समुद्र में हैं और समुद्र से जुड़ी हुई बातें हमको कर रहे हैं, आगे कुछ दिनों और चलेंगे। आज भी समुद्र से जुड़ा हुआ विषय है। आज हम बात करेंगे कि नेवल आर्किटेक्चर एंड शिप बिल्डिंग के बारे में, कि किस तरह से नेवल आर्किटेक्चर और या नौसेना वास्तुविद्या और जहाज़ों का निर्माण होता है, इसके बारे में सारी डायनामिक्स आज हम समझेंगे, स्टैटिक्स समझेंगे। हमारे साथ बहुत ही उत्कृष्ट स्पीकर हैं, बहुत ही उत्कृष्ट वक्ता हैं, जो कि बंगलौर से हमारे साथ जुड़े हुए हैं। मैं आपका उनके साथ थोड़ी मुलाकात कराता हूं, उनके बारे में बताता हूं। दोस्तों, कैप्टन NS मोहन राम, विशिष्ट सेवा मॉडल। ही हैज़ डन over a career of spanning over 6 decades. Captain Mohan Ram worked as a lecturer, naval designer, head of design of Madgaon Docks and head of Mukund Steel Plant, Mumbai. From 1989 to 2020, he worked with TVS Motors Limited, which was earlier known as TVS Suzuki Limited, as president, director, projects and finally the consultant. Captain Ram graduated from the Indian Institute of Technology, Kharagpur in 1958 in naval architecture with top honors. He worked as a lecturer at IIT for a year or so and turning down a scholarship for pursuing the doctoral program at Massachusetts Institute of Technology, MIT, United States, before joining the design cadre of the Indian Navy. He was trained in warship design at the Royal Naval College of United Kingdom and worked for a year at the Royal Navy Design Establishment at Bath, UK. He is a gold medalist, MBA from Faculty of Management Sciences, Delhi University in class of 1973. A pioneer of designing in Indian Navy, he designed yard craft, seaward design boats and landing ship tanks. He was also the project officer of Indian naval ship Godavari, India's first missile design frigate. He was later absorbed in Mazgaon Docks Limited MDL in 1980 and retiring as captain from Indian Navy. He headed the design function. He was responsible for the design of offshore patrol vessels for the Coast Guard and a number of other crafts. After joining TVS Suzuki Limited, which is now TVS Motors Limited, he designed the TVS Scooty there and then worked as a director projects up till 2001 and then as a full time consultant with TVS. Mohan Ram Sahab is a recipient of many awards including the Vishisht Seva Medal for the design of Indian naval ship Godavari, the FIE Foundation Medal for Excellence in Engineering and Management, the Distinguished Alumnus Award at the Indian Institute of Technology Kharagpur in 2011. In fact, Captain Ram's name figures first in a recent publication titled 100 Top IITians, those who are working in India, those who served India. Captain Mohan Ram is still very active in mentoring and lecturing to young students. He also authored 4 books including a book on automobile recycling. Friends, in today's session we are very lucky to have Captain Mohan Ram. So Captain Ram, आपका बहुत बहुत स्वागत है NCERT के इस प्रोग्राम में। और साथियों, आज हम शुक्रगुजार हैं हिंदुस्तान इंस्टीट्यूट ऑफ मैरीटाइम Chennai, which is called HIMT Chennai, and SED company for allowing us to use their videos in today's program for school children. So we are equally thankful to Indian Navy and to TVS Motors for having collaborated with us in this program. So once again at NCERT I welcome you, Captain Mohan Ram. आपका स्वागत है and it is all yours now. Please continue.
Thank you. Can I start?
Yes, please.
Good morning.
Good morning.
I want to thank NCERT for giving me the opportunity to share some ideas of naval architecture shipbuilding with young school students. And without further ado, let me start. The topic of my lecture is naval architecture and shipbuilding. And naval architecture is the art and the science of designing ships and marine structures. It's an engineering discipline which incorporates mechanics, material sciences, hydrostatics, hydrodynamics, structural design, and integrated electronic systems and software. It's also one of the oldest professions known to mankind. And it's vital for India with its huge coastline, large exclusive economic zone. Now, why is naval architecture important? 80% of international trade is carried by sea. The sea transports crude oil, petroleum products, LNG, iron ore, cargo, food grains, engineering goods, etc. It supplies oil from offshore platforms, and the sea lanes and marine assets of each country need protection from hostile forces and piracy by coast guards and navies. Now, ships are fascinating. They have a unique charm of their own. They mirror life in miniature. People live in them. People travel in them. People work in them. There are accommodation, workspaces, recreation, power communication. It's a small city in miniature. They operate at sea, which can be kind at times and cruel at times. And warships, in addition, have weaponry and firepower they should be able to sustain damage to fight another day. It's not an exaggeration to say ships are among the most beautiful creations of mankind. Now let us look at India's glorious maritime heritage. We have maritime heritage, stretching over thousands of years. If you look at the Indus Valley civilization in Lothal, they've dug out old dry docks. The Rig Veda, Ramayana, and Mahabharata mention sea trade, and Mauryan Empire engaged in sea trade with Greece. The Pallava and the Chola fleets dominated sea lanes in Southeast Asia and traded with Malaysia, Myanmar, Thailand, and Cambodia. The general of Shivaji, Kanoji Angre, defeated the Portuguese fleet. And until early 18th century, India was the leading shipbuilder in the world. A ship built in India is now kept in a dry dock in United Kingdom. Now this is Lothal dry dock after excavation, and after trades it looks like this. Beautiful, isn't it? And it is 3,000 years old. Now the dry dock is 37 meters by 22 meters, and there is evidence of vibrant trade with Mesopotamia and Egypt at that stage. The ships could go to the Gulf of Cambay when dockyards were, and they were in use until 1850. Can you believe that? The channel is 1.7 meters above the 4.2 meter deep dry dock, and the excess water was taken away by other inlets. It is a marvel of hydraulic expertise of our ancestors, and it could hold 30 ships of 60 tons or 60 ships of 30 tons. Now let me come to the India coastline exclusive economic zones. India has a total land area of 3.3 million square meters. 200 kilometers from the coast belongs to India, except where another country, then halfway house is a rule. And the total economic zone is 2.2 kilometers. India has a coastline of 7,500 kilometers. All the resources in this area, the fisheries, offshore oil, other marine resources belong to India, and they need to be protected. Now, let me show a picture of how the Cholas dominated the sea lines. The blue color shows the Chola Empire. The pink color shows the Chola influence. There are places here today even which show Chola influence. And the trade routes are shown, and you can see the Chola went all over beyond Sumatra and whatnot, went to South China Seas, etc. We have a marvelous heritage. This is a ship, Trincomalee, which is kept in a place called Rotherham in UK, built in India and fought in the Trafalgar War. Now, we lost all shipbuilding afterwards due to colonial rule. And the first ship launched in India after independence was Jala Usha. It was launched in 1948 by the Prime Minister. Here is a picture of Jala Usha. Now, let me get on to explain something about marine structures and ships. Naval architects design and build a bewildering variety of marine vessels and structures. They include cargo vessels, oil tankers, passenger vessels, cruise ships, offshore oil production platforms and support vessels, offshore wind farms, we generate wind power from the sea, hydrographic survey vessels, and military surface warships, coast guard and patrol vessels, aircraft carriers, and submarines. Now, how do you design a ship? The first thing you look at what the ship is supposed to do, its mission, the cargo, the load it carries, the number of passengers and the crew. What is the speed the ship is supposed to do? Minimum speed, maximum speed, and sustained speed under specified sea conditions. How far it's supposed to go, cruising radius in days and distance. And some ships have specialized requirements, like tugs require pulling power. Icebreakers should be defined by the thickness of the ice cape they break. Panama Canal ships should be able to transit the canal. So there are restrictions on width of the ships. And for warships, the armament, the guns, the missiles, the radar, fire control, electronics, they dictate the design. In an aircraft carrier, it's dictated totally by the type and number of aircraft operated. I'll show you some pictures of ships and briefly explain them. This is a typical cargo vessel. You can see containers ISO 30-foot containers stacked on the deck, and the ship carries its own cranes, and it can carry different kinds of cargo. This is a pure container ship. These can carry up to 3,000, 4,000 containers, and there are special containers which carry refrigerated cargo also. They are very fast ships, and a large part of the world trade is now carried through container ships. These are oil tankers. They carry crude oil from oil producing countries to oil consuming countries. They're very large ships. They can be as much as 350 meters long and carry as much as 1,000,000 tons of oil. Is the largest tanker built in the world. They have powerful pumping systems. They can discharge the oil in a very short time. Now, crude oil is transported, liquid natural gas, transported from Qatar and other places to consumers in specially refrigerated LNG carriers. Just imagine, it is a larger version of the domestic gas cylinder in your kitchen, but this carries 30,000 tons of LNG. It has very special cooling systems and firefighting and safety systems. Then you have got ore carriers, which are very strong ships which carry iron ore, similar ships which carry coal. Then there are cruise ships. Now, passenger ships will almost vanish because people are traveling by air. But cruise ships are like floating hotels. People go on holidays in cruise ships, and depending on the fare you pay, the facilities you give are different, and it's become very popular vacation system. Tugs are like jeeps of the sea. They pull and berth ships. They do salvage, they rescue, they do firefighting. They're very powerful small ships like little boxers. Offshore oil platforms are permanently secured to the sea. They produce oil and flare the subsequent case. This is a photograph of an offshore oil platform from Bombay High in India. Now, they are supported by special vessels called multi-purpose vessels. Now, these vessels carry divers. There is a hole in the bottom called moon pool which can be closed. And the diver goes through that hole and can go as much as 300 feet, 300 meters below the sea. And he is connected to the land by a tether and by a complicated communication system. He breathes a special mixture of oxygen and nitrogen. And the ship has to stay in one place. They have got positioning systems which allow the ship to remain in one place in spite of sea conditions. Nowadays, countries like Germany and Denmark have started producing oil, wind turbines, which use non-conventional energy sources. These are windmills which are located in the sea, and from there the power is transmitted to land. Let me come to fighting vessels. This is a Coast Guard vessel. The Coast Guard is a paramilitary force which looks after marine interests of India in the EEZ. It takes care of sea air rescue, anti-smuggling, anti-piracy, and anti-pollution control. Now, this ship is CGV Vikram, which I had the honor of designing and delivering in Mazagon Docks in 1980. These are survey vessels. A survey vessel, like a land surveyor, it surveys the sea depth and prepares charts. These are very, very important because the sea bed is continuously changing and the charts are updated all the time. They have the capacity to go at very slow speeds, stay at one place, and very sophisticated equipment. This is a landing ship tank. It's an amphibious ship. It can land in shallow beaches, and if you see there is a, oh sorry, there is a bow door here. The door can open through which tanks can roll out. They carry battle tanks. They also carry troops for landing. They carry assault craft and all. They can land a helicopter at the back. So these are very versatile ships. India has got a number of them. I had the honor of designing the first of this class called INS Magar, which was built in 1980s. Now this is a floating dry dock. Instead of dry docks in the land where the space availability is a problem, now floating dry docks float and ships are docked inside the dry dock and maintained here. Here you see a floating dry dock with two ships being maintained inside. And it's interesting, India also built its first floating dry dock by Larsen and Toubro, Kattupalli, Chennai a few years ago. Now this is India's first indigenous warship, ANS Godavari class. This was designed in the 70s, delivered in the 80s, and after 30 years of distinguished service, these ships have been retired. Now look at this ship. There is a gun at the front. There are missiles, land, surface-to-surface missiles, surface-to-air missiles, fire control systems, the helicopter landing at the dock, some anti-submarine facilities also. This ship was the first ship totally designed and built in India. I had the honor of being the project officer for this ship. Now, India has built nuclear submarines. Now, the Arihat, and the third submarine is getting a nuclear submarine has an advantage, can stay at sea for a long time. And it is a very, very major step forward for India. And I am very proud that the organization which I joined, which is a very small organization today, has got fantastic capacity to design nuclear submarines. Now this is INS Delhi, which was came after INS Godavari, bigger ship, much more capable. It's a world-class ship. These are the latest ships built by the Indian Navy, INS Vishakhapatnam. If you see here, the lines are much cleaner than Godavari. The sides are tilted, and there is a special paint used. They have very low radar signature. They have got stealth capabilities. Now this is the pride of India. This is INS Vikrant, 45,000 tons, can land number of aircraft and helicopters, totally designed and built in India. India is one of the few countries in the world which has built and operated aircraft carriers. And this has been done entirely by young naval designers, men and women, located in Delhi, and detailed development done by Cochin Shipyard. And this is a matter of great pride to India. There are two occasions where Indian ships were lauded in public. When Godavari went to New York for the 200th anniversary of US independence, the Time News magazine carried a headline, India emerging naval superpower. And similarly, when Vikrant was operational, the world press was amazed at look at the clean lines of the ship. It's a beauty, and this is done entirely by young Indian designers. Now let me explain to you, with a simple video, various parts of a merchant ship. This is the length of the ship from front to the back. And these are cargo holds, in which cargo is carried. These are the hold, this is the beam, is the width of the ship. And various types of cargo can be carried in the cargo holds. It depends on the cargo, the method of storage is different. And it's an expert job to load cargo, it's called steam lowering. Now these are deck cranes, different kind of cargoes. This is carrying timber now on the top. You can see the cranes which are operating here. Now this is the holds and crane. This is carrying pipes on the deck, upper deck. These are two funnels here. Now you will see containers being loaded. Cargo ships can carry containers also on top, like the picture I showed you in the beginning. Now this is a life raft which is going out. This is a propeller which propels the ship. That is a rudder which turns the ship. The same system is used in small boats. And now I'll take you around the engine room of the ship. This is the engine room of a ship. This shows the main propulsion engines. It can be diesel, it can be gas turbine, can be steam turbine. This is the engine here. These are the exhaust gases going on top, go through the funnel.
Right, sir.
Now, wait a minute, it's coming. Now you'll see the gearbox now.
Yes.
And the shaft will take the power. This is a gearbox. This is a shaft which goes to the propeller, and you will see the propeller turning from the shaft.
Yes.
And these engine rooms are, this is the propeller, that is a rudder here.
Yeah, such huge
This
engine
is the
rooms.
exhaust which is going through the funnel
Uh-huh.
to the top. And these are the accommodation where people live here and all. And you see the boats here, lifeboats.
Yes.
This is auxiliary machinery, and these are operated by marine engineers. And nowadays it's very hot and loud in the engine rooms, so people have air-conditioned control rooms. Most of the machinery is remote controlled. That is air conditioning system, power generation, etc.
It's an engineering marvel.
And now, after this, I'll show you a picture of ship motions.
Okay.
This is about ship motions. Okay.
Yes.
it's working good. Yes.
Not picture, Ganapur. Okay.
Yes,
Yes, yes.
These are 6 types of ship motion.
Okay.
Boys, now, this is called pitching.
Okay.
The fore and aft motion of the ship. It operates over x-axis. I'm talking. This is the rolling, sideways motion of the ship. This is a ship rolling, which is called list. This is yaw. This is the fore and aft motion.
Definitely not for a weak heart.
Heave is up and down is heave.
Yeah.
Up and down motion of the ship is called the heave. Sideways motion is called sway. Transverse motion ship is called sway. The fore and aft motion is called surge. It's a linear motion. And the combination of all this is how the sea moves.
Yes.
You can see when the sea is rough, the ship flexes quite a lot. Don't be scared, it's quite common. This is common.
But yeah, not for the weak hearts, of course. It looks quite dangerous and scary.
Now, I want to clarify one thing. Naval architects only design ships. They don't go to sea.
Yes.
Others go to sea.
True,
So
true.
some of you want to become naval architect. If you are scared at the sea, remember, you design the ship, somebody else goes to sea.
So you
In
can,
fact, my book on my memoirs I written, My Ship Sailed the Seas, But I Stayed Ashore, was the title of my ship. Now, how do
absolutely.
you become a naval architect? There are entry tests after 10th, 12th grade, 10 plus 2. Institutions which offer naval architecture courses are IIT Kharagpur. We started in 1952. I was from the second batch. IIT Madras, Cochin University of Science and Technology, IIT Delhi, which trains Navy and Coast Guard naval architects, Andhra University, Visakhapatnam, Academy of Marine Education and Training, Chennai, and a few other places. Now, what are the subjects which are taught in naval architecture? Common engineering subjects like math, physics, chemistry, applied mechanics, etc. Then about stability, safety and oscillation of ships. Then structural design, hydrodynamics, resistance, propulsion and steering of ships, about the power required and how the ships are turned. Sea spectra and sea keeping of ships. The sea may look very complicated, but can be mathematically modeled. Its energy is taken in sea spectra, and how ships behave in the sea has to be part of design. Shipbuilding with practical training, design of various types of ships, and regulations and contracts, which are very important in naval architecture. Now, what are the employment avenues for naval architects? Now, there are a lot of jobs available. Shipyards and ship repair yards offer jobs. There are boat builders all over India who require naval architects. There are regulatory agencies and classification societies like Lloyd's of London, American Bureau of Ships, Indian Register of Shipping, Bureau Veritas, which is French, Norske Veritas, which is Japanese. There are testing agencies in model tanks. There are model tanks in Chennai, in CW, Central Water Power Research Station, Pune, at IIT Kharagpur. The Navy has got its own testing laboratory. There are specialized design outfits which offer design services to shipyards in India all over the world. There are consultancy organizations, and the largest employer is the Indian Navy. Now, let me talk about major shipyards in India. Mazagon Dock Limited, Bombay, and Garden Beach and Goa shipyard are owned by Defense Ministry. Mazagon Dock Limited is the first warship builder, and it built INS Nilgiri class. It built the Godavari class and all surface frigates. It has also built the submarines for the Indian Garden Beach shipbuilders and marine louder. Garden shipbuilders engineers, Kolkata, have also built a lot of survey ships and landing ships. Goa shipyard is specialized in Coast Guard vessels and patrol vessels. Cochin shipyard is a merchant shipyard which is under Ministry of Transport, but it built INS Vikrant. Hindustan Shipyard Limited also builds naval ships and merchant ships. In private sector, the largest shipyard is Larsen and Toubro shipyard in Kattupalli near Chennai. They have built floating docks and they have built also vessels for Coast Guard. And there are other shipyards in Gujarat and other places.
Okay.
I want to talk in detail about naval architects in the Indian Navy.
Sure.
Now, the Indian Navy is the largest employer of naval architects. It started with 3 civilians recruited in 1950s. In 57, a small cadre of 18 was planned for maintenance of ships. Nobody thought of design at that stage. 1 or 2 of us were trained in UK. Actually, I was the number 13. I was not unlucky, I was lucky 13. The cadre expanded as the Navy grew, and today it has 400 officers and 20% are lady officers. In this present batch, where 34 were passed out, 17 were women. It is real case of gender parity in the Indian Navy. And it's among the first to recruit ladies and offer permanent commissions. And the ship which went around the world, INS Tarini, was commanded by a lady from this cadre, and another crew member from this cadre. And the lady naval architect officer today is posted as assistant naval attaché, Indian Embassy at Moscow. This is a shining example of Atmanirbhar and gender equality and parity.
Yes.
Now, how do you get into the Navy? Those after 10 plus 2, you write an examination, go to service selection board, enter through cadet entry. And short service commissions are often to engineering degree holders in naval architecture, aerospace, civil, mechanical, metallurgy, etc. Now, the training, those with permanent commissions are trained in the Indian Naval Academy, Edumala, for 6 months, and then they do a 4-year course in naval architecture at Cochin. Then they go to IIT Delhi where they get a postgraduate diploma. Then they do go to Visakhapatnam for practical training in 4 months. Then they do naval courses called sub-lieutenant courses. Then they attach to a ship 3 months for various jobs. Those who are at short service commissions spend 12 months in Naval Academy, but they are not used to the Navy. They go to Vishwakarma, they go to PG diploma, sub-lieutenant courses, ship attachment. The beautiful thing is everybody who joins this cadre gets a postgraduate degree from IIT Delhi. This is something unique for any branch in the Navy. Now, I'm going to show some pictures. They are all ladies. Don't get the impression it's 100% ladies. It's just to show we employ ladies. So these are 5 proud ladies marching on naval dockyard. One of them is a lieutenant commander, others are lieutenants. And they do any job, which anything a man can do, a woman can do. Now here a lady is sitting inside the ship while repairing, examining the pipes and hull structure, etc. There is a guy welding next door, very tough job. Here is a lady who is planning refits. and she's doing with the help of computer and assistants. Now here is a lady in a dry dock who is examining the rudder for rust, etc. Another lady is handling shop floors. Now here is a lady doing material planning. Now, warship model testing, ships before they are built, scale models are tested in towing tanks to check their power requirement and how they handle rough seas, etc. And there are model testing facilities in India today. Navy has got its own huge facility at Visakhapatnam. There are testing tanks at Pune, at Chennai, and at Kharagpur. Now let me talk about computerization shipbuilding. Now, in my time, we used to make ships planes by using batons by hand. Today there are computer programs. This is a program which actually is the shape of a ship designed by a computer. Layouts are prepared by computers today. This is the student layout of an air defense ship. And you can make a solid model in computer to see what the ship looks. This is a solid model of an aircraft carrier. Now this is the 3D simulation of warship design. Remember, it looks very much like INS Vikrant. It was done in the design offices at Delhi. And they're done by people in the early 20s, mid 20s and early 30s. There's a bunch of men and women who are making India proud.
Yes.
I am proud of the pioneer. These are my grandchildren. I am proud of them.
Sure.
This is a virtual reality. Actually, you can create the actual shape inside a hangar. You can make virtual aircraft, move them around. And this is the latest technology, cutting edge. The Indian Navy does all this. And today in the armed forces, Army, Navy, Air Force, Navy has moved farthest in Atmanirbhar. And more than 70% of the ships which operate in Indian Navy are designed and built in India. Now, I want to talk about naval architecture in general. It's an amazing discipline. It has got fantastic sweep. Naval architects are exposed to diverse technologies and manage huge projects involving managerial roles and also many large number of people. When I was in Naval Dockyard as a young lieutenant, I managed 500 people.
Wow.
As a commander, I had 2,600 people reporting to me. So it equips, even if you retire from the Navy, it equips you for roles outside.
Yes.
Because you are trained in this thing. And a ship has got everything. Ship is a microcosm of life. It is a city in a miniature. People live there, people work there, people recreate. It even has a prison for people who misbehave. It has got its own kitchen, it's got its own laundry, its own recreation spaces, its own generation, its own air conditioning. And because you deal with all these things, you learn a lot about diverse things. So people who retire from this service get wonderful jobs in software. Some of them have become experts in air conditioning. Some of them are top jobs in renewable energy. Some of them have got into tractors. So many of them working in offshore industry, in automobile industry, etc. So that even after you leave naval architecture, the world is your oyster. There is no limit to what you can do. Now, a retired officer from the submarine crew, Commodore Verma, headed the design offices of TAFE. He designed tractors which are exported all over the world. Another young officer who left Navy early became a vice president in Infosys. One officer today is the chief operating officer of a very large software company. Take my own case. After I left the Navy, I went to Mazagon Docks. Then I had construction division, where I erected chemical plants, fertilizer plants, worked in atomic power plants. Then I headed India's largest foundry, Mukund Foundry. Then I ran India's largest alloy steel plant at Mukund, and which was producing 40,000 tons of steel a month. Then I became president of a company, TVS Suzuki, today it's called TVS Motor. And having designed India's first missile frigate, I also went on to develop India's first light scooter for women, the TVS Scooty. Now here is some interesting thing. A frigate weighs roughly 3,500 tons. 6 of the designs which I made, when 6 ships were built to my design, 3 to the original design, 3 an improved version. The total weight of the 6 was 21,000 tons. Each scooty weighed 70 kilograms. 10 million scooties were sold. The total weight of scooties sold was 700,000 tons. So by weight, 30 times the weight of frigates was the weight of scooties which was sold. If you calculate by value also, the scooties, so this is the beauty of naval architecture.
Yes.
You can do anything. There is no limit to you. And those who become, and apart from that, it's a delightfully enjoyable profession. So when your work becomes fun, life becomes magic. That is the beauty of naval architecture. Now let me summarize and conclude. As our country expands, our trade will expand, our manufacturing, our business will expand. We need to transport larger share of trade in our own ships. But today, India carries a very small proportion of its cargo, in less than 10% is carried in Indian ships. So we need more Indian-owned ships, and this has to be developed over the years. And Government of India has recently announced some incentives for shipbuilding. Hopefully, India will get its pride of place. Our Navy has to expand considerably, protect sea trade and defend our marine resources. Navy needs more submarines, nuclear submarines, it needs aircraft carriers, it needs smaller ships, conventional submarines, etc. And of course, economics is the dismal science of matching infinite demands with limited resources. So hopefully the Navy will grow large. And as I explained, naval architects handle variety of jobs, exposed to a wide sweep of technologies, and develop great managerial capabilities. Now, I can't think of a more interesting job for a young person to do than to deal with ships. And there will be a steady demand for naval architects. Now, I find in IITs, people with lower JEE ranks go to naval architects. It's a big mistake. I think naval architect can be, I could have chosen any subject I wanted. I chose naval architecture out of it.
True.
It's a fulfilling career for young people with technical bent of mind and a spirit of adventure. I can tell you, when you enjoy your job, when a job becomes fun, it's not a job anymore. It is magic.
Yes.
And I invite some of you to take on to this magic. I want to acknowledge many people who helped me in this telecast. Rear Admiral Mohan Ram, retired. Commander Venkatesh, Indian Navy, retired. Captain J.H. Christie, Indian Navy, retired. He made that beautiful video on the parts of the ship. Commander Sujit Bakshi, Principal Director, Naval Architects, Indian Navy. Commander Hemant Ayan, his colleague, they gave all the beautiful pictures of Navy in operation, training, etc. And finally, I also want to thank the organization which allowed us to use the video on the National Institute of Marine Training, Hindustan Institute of Marine Training, which allowed to use the beautiful video of ship motions. Thank you very much. I hope I was able to share some of the joy and excitement of shipping and shipbuilding with you.
Sir.
I'm looking forward to your questions. Thank you very much.
Thank you so much, sir. So,
thank you very much, Captain Ram. We really enjoyed your journey, and definitely the architecture of Navy ships, etc. Now we are receiving some questions, so we'll talk to you a little bit, and I request Harpreet to start that.
Share now, and we can get on to.
All right. So you can, Harpreet, please start the discussion, and I will.
Yes, sir.
I would like to give some insight to this.
Sure.
Yes, please. Harpreet.
so, sir, we have received a few questions, and there is
Question,
one.
you have send it me by text because
Sure.
my hearing
Sure.
is not great.
Absolutely, sir. We will send you the questions, and these are very important and relevant questions that we are receiving from our audiences. So, this is one particular question that, of course, we have received, that there are different types of ships available. Now, the student wants to ask you that what are the types of ship?
So Harpreet, I will take on at this point.
Yes, please.
Text
Children,
it, please. I can't hear.
don't worry. I'm answering.
Yes.
So the question is
You text it on
that
True.
see that there are several types of ships, my dear friends. There are some ships are designed to carry liquid bulk, which have a lesser freeboard, and there the ships are divided into several parts, and those ships are called type A ships largely. Type A ships. Then we have type B ships as well, which are designed to carry iron cargo or the solid cargo materials, and they have very high freeboards, and they have very high freeboards, very large freeboards. So, type A and type B, and then we have type C kind of ships. These type TC type of ships were designed by the Imperial Japanese Navy during the World War II to escort the ocean seas. These type C ships were used during that time. Then we had see now as Captain Ram mentioned, the different arms of the naval architecture, mechanics, fluid mechanics, etc., which you have think. There are different other types of classifications of these ships. Let me give you some insight to these ships. We have type 3, we have type 4, we have type 5. Let me briefly give you depending on their densities and depending on their capabilities. So, let me briefly give you the composite material. Those students, those who are in class 11th or 12th have studied some bit about composite materials. You know metal and non-metals, you know there are some mixtures, solutions, etc., but in solids if there are composite materials. You please see the composite materials. Time is short to speak more about composite materials. For example, the wood and the bone, the most beautiful composite materials which we have is the bone, is the human bone. So, now these composite materials are used nowadays to make the ships. So, the most beautiful material for that kind is carbon fiber. Carbon fiber is used to make the ships which are lighter, much lighter in mass, therefore much lighter in weight. So, they can have better productivity, better efficiency. But in type 4, material ships, what happens? We use the inner linings of polyamide or polyethylene plastics, etc. So, these ships are indeed very high strength, but has low weight. Now, we are having type 5 ships. These are again carbon reinforced materials, fiber materials, which are fibered with the metallic compounds as well, the aluminum or iron or some copper or some other materials of that kind. So, but these type 5 ships do not have any inner lining.
Okay.
So, they have more efficiency. So, we have different type of ships. So, can we move on to our next question, please?
Yes, sir. Also, I would like to ask you that who is the father of naval architecture?
So, the naval architecture was started. French scientist, French engineer rather, Pierre Boyer is considered to be the father of naval architecture. He was born on 16th of February in 1698 and he passed away on 15th of August 1758 in Paris. And he was indeed, basically he was, as Mohan Ram Saab was speaking about what to be studied, those are the verticals which are for natural naval architecture systems or studies, mechanics, fluid mechanics, style, design, etc., and then designing, mathematics, science, etc., all those kind of things you have to study. Yeah. So, but the Pierre Boyer was the French mathematician and geophysicist, geodesist and astronomer. Quite a knowledgeable person, quite studied. So, he was considered to be the father of Indian Navy. Right. Father of, I am sorry, please, I beg pardon, father of naval architecture. But at the same time, our own Chhatrapati Shivaji Maharaj is considered to be the father of Indian Navy systems, Indian naval architecture systems, who did a lot, who was quite visionary and who did a lot for Indian such ships or the movement of the cargoes through the ships. Remember, as Professor Ram said that ships are most probably the most beautiful creation of mankind ever.
Absolutely.
So, friends, so can we move on to the
Yes,
next question?
sir, we have one more question, and one of the viewers is asking that distance in sea is measured in nautical miles. Can you please elaborate on that?
Yes, this question has been coming, colleagues, repeatedly to us. Nautical mile.
Yeah.
See, on surface, on ground, when we do measure the distances, we measure the distances in kilometers or meters, which we know. You might have, children, you might have also heard about the unit of distance as mile, which is nearly 1.67 kilometers or so. What is nautical mile? We have explained it earlier also in the case notes session as well, but let me do it again. Nautical mile. See, you know the earth. The whole earth is spherical in nature, and there is the center of the earth, which is a point, the center of the earth. Now, you know the angles are measured in degrees, and the portion of degree is minute, and the further portion of minute is a second. So, the 1 degree is consisting 60 minutes, and 1 minute is considering 60 seconds.
Right.
Right. So, now if you are at one point on the surface of the earth, suppose, and if you draw the line touching it to the center of the earth like this, and if you move on the surface of the earth by some distance, and if it makes 1 minute angle, the angle between the two lines is 1 minute, then this arc length is called 1 nautical mile. Is nearly roughly 1.8 kilometers on the surface of the earth. Remember, the nautical mile is a unit on its own. Nautical mile is a unit on its own. It might have a different distance on the surface of the earth and 800 kilometers above the surface of the earth. For ISS, it is different. For surface of the earth, it is distance. Because remember, this is the arc length. This is the arc length which has different values at the center of the earth and at the somewhere at the space of the earth. Similarly, in the so the distance, if you try to convert these distances into kilometers, on surface of the earth it is roughly 1.8 kilometers or so. I do not remember exactly. Please give me a pardon, please. But on the surface of the if you move ahead, say 100 kilometers, 200 kilometers, 400 kilometers. So, this distance will keep on increasing, and if you go in the beneath of the earth, this distance will be decreasing. However, these distances are very little. So far, we have been able to dig the earth by 12 kilometers only.
Oh, wow.
The deepest hole which has a human made so far is only 12 kilometers, not much. So, even to reach at that point is very, very difficult. Only once it has been done, you can read it more on, you Google it down, and then you can read it more about it. So, today our time is running short.
Yes.
So, let me, and
So,
if you have some other question, we can take it
one
quickly.
last question we have received, because you were talking about the surface of the earth. It is a related term here that we are receiving. That what do we mean by surface sea?
Surface.
Yes.
It's not the surface of the sea, friends. It's everywhere. Surface. So, surface is defined in terms, see, if you see the hydrostatics, if you read the hydrostatics and the dynamics, the surface is defined by the density. So, the surface of, suppose this is the sea, and suppose some point, if you decide, if you see the density of the material on the some distance in the beneath of the sea, then if the surface is defined, the distance through which the density remains the same. घनत्व जितने एरिया में बराबर बना रहता है, उस जगह को हम सी सरफेस कहते हैं, सतह कहते हैं. उसके नीचे उसकी प्रॉपर्टी बदल जाती है. ये खाली दोस्तों, ये बात खाली सी में ही नहीं है या पानी में ही नहीं है, ये बात हर मटेरियल में है, हर जगह है. How do you define the word surface?
Yes.
Surface is in terms of the density always. So, the density remains uniform. Surface is the distance through which the density of the material remains same, and below which the density changes. In fact, in the case of oceans or sea, at the surface the density is more, and if you go slightly below the surface, the density decreases.
Absolutely.
And then it increases, then it changes on the system. So, somewhere the surface may be as much as 10 meters, as low as 10 meters, and at some places it may be as more as 50 meters or 100 meters, and so far so on.
Absolutely, sir, absolutely. I mean, we can comfortably say that building ships has always been a necessity for both war and commerce. And, you know, this will not change as long as we have oceans and seas to cross. And till that time, naval architecture and shipbuilding will keep on playing an important and I would say an indispensable role.
So, friends, just a second, Harpreet.
Yes, sir.
Captain Ram has mentioned about the Indian institutes where these naval architecture are being studied internationally as well. These courses are being taught at many places, including the Ireland, New Zealand, United States, United Kingdom, etc., etc. So, all the best.
Yes, we have a lot of scope.
Yes, we have a lot
to
of
make
scope.
our careers in naval architecture. And I think, sir, Captain Ram wants to say something. But sir, we are running short of time.
We have lost
Yes.
the connection. In
Yes,
fact,
and I think there's some internet connectivity. So now we would like to definitely wrap up the session over here. It was our 93rd edition of our webinar series, Listening to Learn, where we talked about naval architecture and shipbuilding. We would like to thank both our experts from the bottom of our hearts to, you know, have presented this session so beautifully. Of course, Captain N.S. Mohan Ram and of course Dr. Gagan Gupta for their immense contribution to the session. Now before I close, sir, would you like to mention who's coming next?
Yes, we once again we thank SED company as well as the HIMT for allowing us to use their videos on today's program. Friends, next is on 27th of December, Friday. Then Professor Harsh Gupta will be coming to the studios here, and he will be discussing about the 20 years of great tsunami, Sumatra tsunami.
Wow.
Remember that 20 years ago, a great tsunami hit the Indian coasts and lot of damage has taken place at that time. Still, we have the remains of those damages which was caused, and this program will be in collaboration with the Pravasi Bharatiya Academic and Scientific Sampark Prabhas and Council of Scientific and Industrial Research India on 27th of December. This will be our last program in 2024, and after that we will be coming back with another interesting program by Umesh Varshney from Indian Institute of Science, who is Shanti Sarup Bhatnagar awardee, and the Vigyan Shri awardee on 3rd of January. So, looking forward meeting you on 27th of December, Friday, same time at 10 o'clock.
Right. So, thank you so much, sir, once again. Thanks to both the experts for their wonderful contribution to the session. It's time now for me to close today's session of this wonderful webinar series, Listening to Learn, yani Sune or CK. Now it's time for me to make an important announcement before I finally leave the studio. Yes, it's about an upcoming competition. So what are we looking forward to? The All India Children's Educational E-Content Competition is back for the year 2024-25. We invite teachers, teacher educators, students and independent educational e-content creators to submit their best e-content for the competition. For further details and the registration form, please visit the activities section of our official website www.ciet.ncert.gov.in or scan the QR code on the screen. The final date for submission is December 31st, 2024. And now let's take a look on all the programs that are going to come ahead in the day. So we're just through with the session of DESM webinar series Listening to Learn, where we talked about naval architecture and shipbuilding. In a short while from now, you can watch our session Prashas. At 12 p.m. we will bring you a session in English under teaching learning interventions, and 2 p.m. will be the time for our session. Of course, so details are there in front of you. At 2:30 you can watch a session on the subject sciences, followed by a session in political science, where we will talk about political parties at 3 p.m. 3:30 is the time for a session in mathematics. And of course, simultaneously you can watch Manu Darpan Paricharcha also. From 5 to 5:30 we will bring you our session Sahyog, followed by a session by school leadership and development at 5:30. So that's all for today. This is me, Harpreet Kaur, taking leave of you, but I'll join you very soon. Take care. Namaskar.